Hello, my name is Nathan Ord, and this will be a quick run through of Kerberos and certificates, ways to expand upon accesses gained in a red team or pen testing engagement. It's basically we have the access, so what do we do next? It's a follow on to what we've done with C2s and gaining initial access, and just going a little bit further, specifically in Windows networks. So, just looking at a 30,000 foot view, we have the big ideas here of getting initial access in a Windows environment. So we do have some initial footholds, right, with putting down a C2, a beacon of sorts. Um, so what do we kind of do with that access? Where can we go? And that gets into your lateral movement, moving across hosts, getting an idea of like what we can do across a domain, and then long-term persistence without C2. So you don't really, ultimately, you don't really want to have something calling out over the network at all times. It's just going to end up getting you caught in the long run. So if you can establish means of retaining access to a Windows network, then that will work out best for you in the long run in a red team pen test scenario. For context, on the right hand side is the image of a standard Windows 80 forest layout. At the top, there is the core forest root domain with a bunch of different groups within it, the enterprise admins, domain admins under the central IT team, and that is the core focus right now. We're not going to get into the other divisions, which might be different subdomains, child domains of that forest root. We're just not going to worry about that for now. And then on the left-hand side of that image, you'll see the non-domain joined host in red. That is our box. So our box is a network-attached device that can touch the forest root, can touch devices in the network, as if you had just a black box dropped onto the target environment. And you're just trying to leverage access and go forth and conquer. In this examples that will follow, we're going to make some assumptions about like having access to credentials or collected credentials somehow, either through data leaks online or just doing some basic reconnaissance, social engineering. Perhaps we had responder listening on the network. We captured hashes. We can make some assumptions. We can jump over a couple things just because of the multitude of ways that you can collect credentials in a Windows network. This is not the focus of that. It's kind of stepping one further than that. So, some background here. What is Kerberos? It was introduced in 1987 or 88. The literature is kind of conflicting on it. In any event, MIT was working on a project for a open source solution, or not really open source, but like open solution for authentication. And it was eventually implemented as Microsoft's replacement for NTLM authentication, used for users and hosts. It runs on a ticketing-based system, which we will touch on here in a moment, and it has a few key improvements over the traditional NTLM authentication scheme that's been used in the past. Both are still used currently, of course, because people just don't upgrade for some godforsaken reason. But it comes with some good benefits over NTLM, better security, better it enables single sign-on, so you can use a single point of entry to get into multiple applications or services on the network, and it supports multiple platforms. You wouldn't be able to, in the past, use NTLM on Linux, but because of the open nature of Kerberos, it can be used on Linux now. Super cool feature, makes things handy for integrating different devices into a domain or into a domain environment, and handling authentication in a seamless, streamlined way, if you will. So Kerberos it's not crazy, it's just a little all over the place. So there's a lot going on the screen. I pulled this graphic from Free Code Camp, and there's a few different ways you can represent this. I've done animations, I've done a bunch of different ways of showing this to different people and different groups, but I'm just going to walk through this as I see it. So we start with the user who wants to gain access to a network service, something. So what they will do first is send an authentication request across to the authentication service. The authentication service lives on your domain controller in the forest, which, going back here, it doesn't really show it, but at the forest root domain you have a domain controller, which is your core server for everything Windows Active Directory. Which, noted, this is a Windows implementation of Kerberos. You can do a Kerberos authentication server on Nix. We're not touching that. That's a nightmare. In any event, users will send an authentication across to the authentication service. This lives on your DC domain controller. You'll also see it referenced as KDC, which is your key distribution center. So the authentication service will take that request, which will include like password information and some other key details for authentication, verification, etc. It will check if that user exists and their information is good, and they will issue a ticket back called a TGT. The TGT is a ticket granting ticket. So the way we can look at this is sort of like going to a fair, and you go up to the booth at the fair and you pay money, you put in your authentication, and you buy a ticket for the fair. This ticket is good for everything in the fair. However, you have to validate it to all the different rides that you want to get on. So, a TGT, ticket granting ticket. The user will take that ticket granting ticket and go to the different rides or different services and send a request to a ticket, or to the TGS, the ticket granting service. The service that lives on the network will take that and take it back to the KDC and talk to the Kerberos database, check if a user exists, if the TGS can be actually granted, and everything checks out, and then it will issue a service ticket back. The ticket granting service lives on the KDC for your awareness. There is some communication with the service. The service will say something along the lines of, hey, you're not authenticated, go over to the KDC to get a ticket for me. It's kind of just a back and forth communication stream that's a lot more complex than we need to worry about at the current time. If you want to read into it, there's some links on these slides that you can dig into with. But yeah, so the TGS, once you get a service ticket back, then you can use that ticket to get onto the ride proper or into the service, and then the access is granted to the user. So how do we actually go about doing this? How do we go about abusing this? There's a couple different ways, a couple different tools. So we're going to just take a look at the tools and then get into a demo straight away. The big one that I am most familiar with or most comfortable with is Rubius. However, you can do this with Mimikatz and several other flavors of the same thing. All of them are basically just Windows authentication abuse tools. If you just kind of Google that, look into these two tools, see other forks of these, they've been out there in the wild for a long time, and people have either forked them off and done other things with them or made whole new ones. I know at some point, and I need to validate this if it's fact, is that Benjamin Delpy was like, hey, it's time for me to pass the torch on. Somebody else needs to carry on development of Mimikatz, which is one of the bigger Windows authentication, Windows abuse tools. He was like, yeah, I'm retiring from this, I'm stepping back, somebody else needs to pick up the torch. So expect to see more tools come out that do deep dive Windows research. Again, not the focus of this, but something interesting to go dig into because it is a super fascinating topic, and there's a lot of history behind how Mimikatz came to be, how it came into the public. The person themselves, Benjamin, the fascinating, gentle Kiwi. You can find them on social media all over the place. Worth a read, worth a deep dive if you have the time. I'm sure there's some pretty good YouTube videos covering the topic as well. I think there's details about FBI break-ins or government break-ins and countries trying to get their hands on Mimikatz before it was public. There's a lot there that, again, not the subject of this video, but worth digging into just for a history lesson. But yeah, so let's get straight into it with a demo. What we're going to do is we're going to gain access to a network with tickets. So what we're going to do is use Rubius to acquire tickets using a assumed collected password and target user. And then we're going to use those tickets in some interesting ways here in a minute. So let's go ahead and hop over to the demo and take a look. Okay. So we're back on our red team box that we saw in the slideshow, that red box that's outside the domain but is still able to talk to the network. We're taking a look at the Rubius module, which has a lot of just useful stuff in it. Again, worth a deep dive, worth the time and effort to sink into it and really kind of understand what's going on here. I'll briefly run down what's going on. From the top in settings, which also, by the way, you do have to actually compile this. You cannot get the binary for this. You will pull down the source code, just compile it with Visual Studio. It's not too difficult. There's some instructions out there for it. But anyway, in the help menu for Rubius, when you just run it without any flags, anything going on, you will get a rundown of everything happening here. So from the top, ticket requests, renewals, retrieve a TGT based on user password hash, retrieve a TGT based on other details, different configurations, using certificates from Keystore without pre-auth data, AS rec, different one of the ways you can actually do authentication and kind of one of those sub details of Kerberos authentication. Again, we're not going to get into it. I would highly recommend reading up on Kerberos, but beyond the scope of what we're doing here. Retrieve a service ticket for an SPN, so a service principal name requesting a specific ticket for that. Retrieve a service ticket using the Kerberos key list request options. Retrieve a delegated managed service account ticket. Again, it's just a bunch of different ways that you can request tickets. There's also constrained delegation abuse, ticket forgery. This is kind of the bread and butter core of what Rubius is good for. You will be able to, instead of requesting a ticket from a DC, you can, if you have enough of the details pulled off of a domain controller, including user hash, KerbTGT hash, KerbTGT hash, user account, and user groups, which a lot of that is queryable without actual access to an account. Or some of it's recoverable on a DC itself. There's a bunch of different ways you can go about it. Anyway, you can basically fake the creation of a ticket to use as a master key across the entire domain. So, for example, if you can dump KerbTGT off domain controller, then you can basically fake your way into being any user you want inside that domain. Which has some different benefits and can also help you maintain long-term access. But in this case, a golden ticket would also be good for lateral movement, similar to a silver ticket. Silver ticket would be just as good as well. It's just kind of narrowing the scope of how much access you have into a network, especially for a network where there might be a lot of monitoring. You might have a SOC that you're going up against, some other things. And the various types of tickets that you can forge. Golden ticket is fully offline. Silver tickets are service tickets, those TGSs. Golden tickets are TGTs. Diamond TGT is, if I recall correctly, a online version of the golden ticket. Effectively, you're taking details from other tickets online and then importing them into the golden TGT to make it look a little bit better. Because when you do an offline golden TGT, it doesn't quite look right compared to things that are naturally generated inside the network. So this is just a bit more OPSEC-y blendy. And you get into the local stuff, ticket management, so like how we actually manage tickets locally on the red team box. You'll do pass the ticket, so how you pass your ticket into the session of the terminal that you're in. Purge, just to nuke all the tickets in that session for your terminal. Then you can get into K-list, triage, dump. Again, it's more of that local management of tickets. And then Kerberosting, which is a whole separate topic. I'm not going to deep dive this. For right now, what we need to focus on is getting just details locally. So what we're going to start with is Rubius Triage, which in theory should work, I'm hoping. So we have nothing going on currently. We have our LUID, local user ID, if I recall, or local. It's effectively your session for your login session for how tickets are managed. It's a space where you save all your tickets, and we'll see that here in a second. So what we'll do is we're going to actually just ask the domain for a TGT for this mCoolUser guy with a password 1 bang, assuming that we collected this in some way, shape, or form. And this is going to be our access into the domain without actually being in the domain. So, without further ado, it would help if I included the adequate flags and slashes and other details. Stand by. Whack user. Oh, not supported. Okay. Well, we'll have to dig into this real quick because I need to figure out what's going on. 1 moment. Okay, so we're back. I had to figure something out real quick. Forgot to actually take a box on the user configuration on the DC side of things, and I also needed to force Rubius to use the encryption type of AES-256. However, we were able to successfully request a TGT, so now we can act as that cool user. We can take this and we can pass this ticket, base64 encoded, convert it into other formats if we need for other platforms. If you're using this on Nix, it would use Ccache, different version of curb files. But here, in this case, it is passed into our session with the PTT flag, and we just have access to the domain controller now. If we wanted to query things, if we wanted to run things on target, if this was an administrator, or if we wanted to try and tunnel through to a different box, there's a multitude of different things that we can do with this. But effectively, having this ticket and having the access using this information means that we have access to the domain. We are an authenticated user. It's still going to look weird from the aspect of you're an external device with a ticket from the domain. However, that won't be a problem for very long because you could use this ticket to pivot into a different box, gain access to a box, and, move on from there. So, without further ado, let's go ahead and jump back into the PowerPoint here, and if I can start it back up without everything failing. Oh, there it goes. Okay, well, here, hold on. We're going to undo this because the slideshow got borked. Stand by. Switching on the actual capture. Turn that off. Turn that on. Okay, so now that we have access with tickets, now that we're inside the domain, effectively, we have the access we need to be able to pivot onto different hosts, different boxes, the DC, etc. Let's say we use that, we are persistent in a way that, it's calling out, beaconing to our C2 server that we talked about earlier in the semester. We need to look at the long term. What does the long play look like here? And the one thing that you will encounter in Windows environments that are properly configured with proper group policy and proper rules and proper training in place, which, you won't get all the time, but if you're lucky and, you have a fun engagement, that'll be the case. You'll find that passwords change, hashes change, all the details of users change. So what can we do to kind of prevent this change from, harming our accesses that we have into a network? We won't, if a password changes, we're not going to be able to recover that password easily, especially if it doesn't get leaked or something, or we find it online, whatever, doesn't matter. The approach we can take here is something that was discovered back in 2021 or published back in 2021 by SpectreOps and a few different other places, which is using public keys. So you can tie public keys in the same way, much in the same way you would tie like a password to an account. You can tie a public key to an account. You can also tie it to a computer or I think technically a service as well. Effectively anything that can have what is quote unquote a user account in a Windows domain, you can tie a public key. So in the example here that you see, part of the initial authentication when asking for a TGT is that AS request, authentication service request. You will kick over your authentication data with like timestamp encrypted with a password, so it's something that the KDC can recognize. It will take that, do all the validation steps, and then kick back, hey, you get a TGT because your password and the timestamp checks out. Again, if the password changes, you're kind of cooked. So what you'll do is you'll take the pre-authentication data with the the private key on the client side. Public key will be sent up to the server to do that authentication, and you just maintain that private key as a adversary, red team, or pen tester. And then at any point, as long as that public key on the KDC side does not get deleted by a well-knowing, all-knowing, all-seeing blue teamer defensive person, you'll have persistent access, because that's not going to change. A user's not going to jump in there and change that. And as far as I'm aware, I think you can have multiple of these keys in the long run, so you could just append this onto the bottom of a list of users' public keys. However, it's less likely that you will see multiple keys. It's also less likely that you see the environment for keys, because it does have some prerequisites, including enabling certificate services on the domain. However, if you do see it in a domain, this entire process is possible. And again, this gets us to the long-term persistence in a Windows network, which is kind of the ultimate goal, without having, a C2 beaconing out constantly, running the risk of burning your infrastructure, exposing you, etc. So, what can we use for this? It's similar, easy process to doing your ticket requests, and it actually builds on that. I forgot to update the picture here. That's my bad. I'll do that in post. Don't worry about it. Whisker and PyWhisker. Whisker and PyWhisker are effectively the same. Whisker is just a C# implementation, and PyWhisker is a Python implementation. They're effectively the same tool. Both are means of creating private and public keys and just shipping the public key over to the KDC for a specific target user. Very straightforward usage, and we're just going to get into it and show it with the demo, using certificates for access or creating certificates for access. If I can get away. Okay, so we're back in the Whisker tool. Just taking a look at everything that gets printed out, similar to how we did Rubius. You get list, add, remove, clear, so some pretty basic setups for getting values for the MSDS key credential link attribute of a target object. So the MSDS key credential link is where that public key is stored on your DC, and by extension the certificate server that lives inside the domain. You'll find that a lot of this formatting is very similar to what you see in Rubius, what you see in Mimikatz, a lot of these other tools. I can't verify this, but I have to imagine it's very intentional just for ease of use. But in any event, with the context that we have of the ticket successfully imported, we should in theory be able to just request TGSs as we need. On the backside, automatically with the tooling, with Whisker, fingers crossed it actually works. But what we're going to do is we're just going to add a key to mCoolUser on the domain, hitting that DC, and let's see what happens. So we go ahead and rip this. No pass was provided. No. Username or password is incorrect. Okay, so after digging into it, it actually I did some testing here. The main thing I did was I realized that I was using an IP address for the DC. When it comes to Kerberos authentication, you primarily need to use the actual FQDN rather than the IP address, because if you're using an IP address in Windows authentication, it will fall back to NTLM, whereas a FQDN will force Kerberos or use Kerberos primarily. However, with some research on the GitHub, it turns out that Whisker, the executable itself, does not support using tickets as the authentication method for passing in the actual private or public key to put onto the KDC. So taking a look at the GitHub for for Pie Whisker, and I will pull this up here. Stand by. So going through it, it has a very similar layout, similar function. It is made to be basically interoperable with Whisker. Whisker's just kind of the older, less shiny, less fancy version here. Has all the same features with a couple added things. Ultimately, you still have your add, your remove, your clear, but the bigger deal is that it supports the following authentications, including clear text, pass to hash, so you don't technically need to do all the Kerberos stuff we did, but you'll see that more domains are getting towards Kerberos and that scheme of authentication, so you will want to know how this actually works. So you can do pass the key, pass the cache, / pass the ticket, or pass the cert. So what you'll do is you will plug in similar information using Pie Whisker. You'll set your target to be your user. You'll set your DC IP address and the domain as we did in the example previously. The other detail you will add in here is using TechK for Kerberos, using Kerberos authentication. You could also use like an AES key here if you've dumped that previously, or a plain text password. It is kind of your call on that one, whatever's easiest. I believe that TechK would probably ultimately be the easiest. I'm not entirely sure exactly how it will do pass. I guess technically pass the cache comes from Ccache file, which is that Linux format that we talked about. So you would have to, on a Nix box, which Pie Whisker will be easiest to install on. I just don't have one available at the current moment with my current setup. You will do this on Nix, install all the tooling, and then pull the hash, the base64 blob that we pulled across or got earlier from the TGT. Load that up onto the Nix box and do a conversion to a Ccache. There's a number of tools that will do this. You can just kind of Google for that and figure that one out. It's not a crazy difficult thing to do. But from there, you will just take that and then effectively profit. Once you get the actual cert or private key and public key handled, you maintain your private key, upload the public key. Once you have that ready to go, you can take that back into the Rubius tool and authenticate with that going forward. And obviously, it's harder to catch, right? Like, it's not something beaconing out. It's just maintained access into a domain, especially if you have network access. Obviously, you should probably maintain network access by, living on the edge, living in routing devices, living on, random things that probably aren't going to be observed as much by blue teams or defensive teams. Just something to keep in mind, but that is also outside the scope of this presentation and more just personal preference and research to do. However, that pretty much covers it. I don't think there's much else to get into here, so I appreciate you tuning in and hope you learned something or took something away. All the links will be available in the presentation and, that you can pull down as you need. Cheers.